Hello and welcome to my session on celestial objects, the objects that are up in space. I'm going to quickly introduce a whole range of objects which may come up within the astrophysics unit. We'll start off with the moon, a big chunk of rock which is thought to have been produced when planet Earth collided with another planet-sized object, and the moon was the chunk of rock which got knocked off. The moon is our only natural satellite, so therefore it's caught within the gravitational pull of planet Earth and rotates around us. The interesting fact is that it is also has its own axis, but what happens is that it rotates on an axis at the same rate as it rotates around planet Earth, so we only see one side of the moon ever. And the far side of the moon is not seen by us. It still receives sunlight from the sun, it just means that we do not see it. So after the moon, let's think about the planets. So these are the inner planets. We've got from the sun outwards, Mercury, Venus, Earth, and then Mars. These are all rocky inner planets, which means they have actual surfaces. However, due to proximity of the sun and also the existence of effective atmospheres, none of these have the ability to harbour life in the same way planet Earth does. For instance, we can see that Earth is dominated by all of that water, and there's not an abundance of water on any of these other planets in the liquid state, at least. As we move out of the solar system, we then come across an asteroid belt. An asteroid belt is basically made up of a series of large rocks, which are thought to have been a planet which never really came together. So these are the distant remnants of a planet. And these have a range of sizes, and some of the larger ones have actually been named, but there are many asteroids within the asteroid belt. Beyond the asteroid belt, we have the gaseous giants, Jupiter, Saturn. These are giant planets, and they are actually gaseous. They don't have a solid surface. They're made up of a range of chemicals and are often traumatically impacted by weather systems within those clouds. Saturn also has what's known as rings around it. Now we have Uranus, Neptune, and finally, I've said the relative size of all planets plus Pluto. Pluto used to be known as a planet, but has been reclassified as not a planet because of the fact that its moon, it actually is large enough or very similar size to Pluto itself, and they rotate around each other. And a requirement of a planet is to rotate around the sun on a steady ellipse, and the Pluto rotating on its around its moon does not fulfill this requirement. All of these things rotate around our sun. The sun is a star in the middle of the solar system, and it is far more massive than any of the planets that we have. As it happens, our sun is known as a main sequence star. Now that just means it is a star living a very normal life. In a main sequence star, the forces of attraction pulling the particles inwards are balanced by the forces acting outwards due to the huge temperatures inside the star. So these two factors balance out. Now we have these huge temperatures because stars are basically nuclear reactors that use hydrogen as a fuel and during its main sequence, so this main normal life star, a star will release energy by converting hydrogen and helium light elements into heavier elements and producing radiation pressure, which obviously counteracts the gravitational attraction of the masses towards the collapse of the star. And as it happens, our Sun is an example of a main sequence star right in the middle of about a 10 billion year lifespan. So this is pretty much how our Sun is going to be for the next 5 billion years. So what object from the solar system is shown here? Well, I've mentioned planets, I've mentioned asteroids, I've mentioned the moon, but nothing with a tail on. So this is actually a comet. A comet is a lump of ice and dust and rock which also orbits the Sun, but often it has a much more extreme ellipse, sometimes coming very, very close to the Sun and sometimes flying well out beyond potentially Pluto. They still have a regular orbiting pattern. For instance, Halley's Comet, which is a very famous comet, is seen once every 88 years on planet Earth. So what makes up the solar system? Think about it. The Sun, the planets, moons, which are natural satellites of the planets, asteroids, and comets. And which of these is a light source? Only the Sun. That is the star, and that's what produces the light within our solar system. So our solar system is a star, and a star is actually, our Sun is part of a wider spiral galaxy. So this consists of lots and lots of stars. There tends to be a central bulge of generally older stars, and then what we have extending outwards are these bright arms which rotate around the central bulge. And as it happens, we sit about midway on an arm of the spiral galaxy. And we can see this when we look up in the sky, when we see the Milky Way. If you're lucky enough to have a very clear night and you can see the Milky Way appears to be a milky stain across the night sky. But that milky stain just means that there's so many stars you cannot distinguish between them. And that's us looking through the arms of a spiral galaxy. We also have elliptical galaxies. So these have a cross-section but no spiral arms, and they actually have a real range of shapes here. Some are very spherical, some are nearly flattened, and the size also ranges from hundreds of millions to over 1 trillion stars. So elliptical galaxies. And we also have irregular galaxies. These seem to have no specific structure. We've got examples of the large and small Magellanic Clouds, the nearest galaxies for us, and these are an example of an irregular galaxy. We've also got a ring galaxy existing there, Hoag's object. But as we see, if we look at the classification of galaxies, there's a real range of different shapes. If we look into the sky, we often see what are considered constellations. These are patterns of stars in the sky which are deemed to describe a picture of an object. In this case, we have Orion, we have Orion's belt, we have Orion's sword in the sky. Now, some of you may be disappointed to know that just because they appear to be near each other, this is only an appearance. If we think about Orion, what we have is a number of stars at very different distances. They just have different brightnesses. And in fact, not all of them are stars. We also have the Polaris galaxy, which is a star within the Orion constellation. If we look up at some constellations you may recognize the Big Dipper. And if you look at the N2 stars of the Big Dipper, they point up to what is known as the Polaris, or the North Star. This is not the brightest star in the sky. However, it is the one star just about is located above our pole, So if I looked at the sky with a camera and put it onto a long exposure, we'd see that the stars seem to rotate around, and that is due to the rotation of planet Earth. But the pole star, the North Star, seems to stay in one place. We also have nebulae. We have the Eagle Nebula and the Cone Nebula here, and these are star-forming regions, and they're giant clouds of gases. We also have nebula formed, and these are known as planetary nebula, and these are formed from the gases of shells of low mass stars when they die and they transform into white dwarfs. And this is a conversation I'm going into much more detail later on in the unit. Supernovas, these are the explosions of much more massive stars. We've got some great pictures here, and we're talking about supernovas. This is the death of massive stars, again something which we're going to cover later on in the unit. Now, how far away these things? We're going to be talking about astronomical distances. Now, I've got three typical astronomical distances here. We have the astronomical unit, and this is actually the average distance between the Earth and the Sun, and it happens to be about 1.496 times 10 to the 11 meters. We have parsecs, and we're talking about that next session, exactly what a parsec is. It's another measurement of distance. And we also have a light year, which is the distance travelled by light in 1 year. Now, what I'd like you to do is just take a moment and, this is a hands-on activity, to construct a table showing the relative distances of the following features of space in both meters and light years. The Moon, the Sun, Pluto, our nearest star, our nearest galaxy, and the most distant observed galaxy. And I think when you see these numbers, you'll get a better understanding of what scale our universe is really about. So, final recap. Can we put these objects in the correct size of order? Smallest first. Take a moment there. The Earth is the smallest. The Earth orbits the Sun. The Sun is the center of our solar system. The solar system is just one system within the galaxy which makes up the Milky Way, and this is one of many galaxies within our universe. So, final another task. Can you match the words with the definitions? Take a moment there. So we have a star. Our Sun is one of these. A planet, there are 8 of these in the solar system, and the Earth is one. The solar system is the Sun, planets, Moon, and asteroids and comets make up this. The universe, all galaxies and everything else. And I have a galaxy which is billions of stars together, and ours is called the Milky Way. So that's my quick introduction to the celestial objects in our